Using containers for game server hosting.
Why would you consider using containers and container services like Amazon Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, or EKS, for hosting game servers? There are several benefits that match business and technical requirements for games. The main point is that a container is an abstraction. It abstracts the application away from the infrastructure. Its purpose is to allow developers to focus on applications and coding rather than DevOps and infrastructure management. There's a strong parallel here with game servers. A game server is also an abstraction, and its purpose is to enable game developers to focus on the game application rather than game hosting infrastructure. If you get the mapping right, container technologies can provide a significant advantage over developing a game server hosting solution using EC2 instances and AWS core services. For example, game servers map nicely to Kubernetes pods, and the orchestration service can be provided as a simple microservice, in keeping with containerized design philosophy. You'll also learn about continuous integration, continuous deployment, or CI/CD. This is a way to improve the quality of game software by streamlining the development process using a development to gameplay pipeline. To begin this journey, you need to know a little bit about containers and container orchestrators that run them.
A container bundles application software with dependencies, making a portable bundle that can be run in multiple locations. Docker is an open source tool for bundling software into containers. Its primary value is that it can bundle the dependencies inside the container with the game software. Without containers, handling software compatibility and dependencies often involves configuring the virtual machine instance and installing compatible versions of software, which is DevOps work. Containers move software compatibility into the build process, making control over compatibility more accessible to game developers. So it helps the game developer focus on game development rather than infrastructure management. You can create a game server inside a container. Containers fit the workload of a game server because containers are lightweight, start quickly, and provide efficient usage of the EC2 instance where the container is running. Docker also provides a container runtime environment that can host and run the game server inside the container. This enables the containerized game server to be run on multiple platforms, including on-premises, in a colocation data center, and in the AWS cloud. Another benefit of Docker is that you can divide a game server into parts, each running in a separate container. This can be useful if you want to move from a monolithic game server design to more of a microservices design. One benefit is that the number of containers can scale separately, which might be more efficient. Of course, the more you divide the game server software into separate containerized services, the more networking, security, and communication have to be managed between containers. So, dividing your game server into multiple containers is more complicated to set up and implement than using one container for the whole game server. A container orchestrator is like a scheduler for containers. The container orchestration system does a lot of the game server hosting work for you automatically, if you match the container abstractions with the game server abstractions correctly. Developing a game server hosting solution using containers has advantages over using Amazon EC2 and AWS core services. Kubernetes and ECS perform container management, such as selecting an instance on which to run a container, setting up resources for containers, including VPCs, setting up security for containers, setting up access to external services, and deciding when to shut down or replace a container. Because container management is similar to game server management, you can use Kubernetes and ECS built-in functionality to perform game server management. Kubernetes and ECS also perform instance management, such as instance configuration, software installation and maintenance, monitoring instance state, and determining when to scale up or scale down the number of instances. On EC2, you have to do this management yourself. Container technology is mature. There's a lot of code publicly available. Whatever kind of workflow you may have in mind, the chances are that you will find code examples that will help.